There are a couple of things we still need to do with our smart contract. If we're going to perform a successful arbitrage, we need to finish off our execution function. That will be where we have the callback, we've received the funds, we've decoded our data, and now what we need to do is actually go and route our process through the right exchanges and to perform the right swap. So that's what we're going to do right now in this video. And then after that's happened successfully, we also need some code that will also successfully repay the flash loan. So if we don't repay it, it's as though it never happened. So the arbitrage then never would have happened. And so we'll do that more in detail in the next session. But in this session, we're going to write our code to perform swaps on PancakeSwap V3 and PancakeSwap V2. And if you're confident on adding other exchanges with the process we're using here, you could quite easily go and do that. At the top of your flash loan contract, just go and put in using safe ERC20 for IERC20. And as discussed earlier, we need that to do safe transfers. And just for good measure, we may not use it, but I'm going to put in here using safe math, and that will be for uint 256. And that's just in case we need it. But these have now been attached to our types for IERC20 and uint 256. So let's just get that done now. And so what we want to do is create some constants that will represent our Uniswap V2 router contract and our Uniswap V3 router contract. So the first thing I'm going to do here is I'm just going to go to Google and I'm going to say PancakeSwap, because it's actually not Uniswap, sorry, PancakeSwap V2 router contract address. And make sure that you get this from the right source on Google. So if I go here to router V2 from the actual docs from PancakeSwap, this will ensure I'm getting the correct address. And here it is over here. It's going to be this address that we will use. So let's go back to our VS code. And over here we can say Uniswap V2 router 02 constant, and that we will call PancakeSwap, and that will be V2 is going to be equal to Uniswap V2 router 02, and we're going to wrap it in this contract address over here. So that we will wrap in there as such. And also what I'm going to do is go to BSC scan and just punch that in, because I don't want it as the contract address from the website. I want it formatted exactly right. And so, you know, this BSC scan is really good at doing that. It'll make sure the lowercase and uppercase is exactly as it should be. So I'm going to just take that back here again, get rid of that. And now I've got the lowercase and uppercase letters pretty much exactly as they should be. Okay, brilliant. And the next address I'm going to need is going to be ISwap router, and that's going to be constant, just like the one above. PancakeSwap, instead of V2, it'll be V3, and that's going to be ISwap router. And now we need the router address for PancakeSwap V3. So here we can get that from Google, and we can just say, or in fact, I've got it open here already. Remember, we looked at the docs.pancakeswap under the V3 contracts, and here is the swap router address here. Remember, I provided a link to this 2 videos ago, so you should have this by now. And let's just copy that over here. It's the one that ends in B14, and let's paste it in there. And again, I just want to make sure it's the right formatting. So here I'm going to go to BSC scan, paste that in, make sure that it says, yep, PancakeSwap swap router V3, and I'm going to copy that. And again, just make sure that I've got it formatted exactly. I don't think it changed at all, but rather safe than sorry. Excellent. Now that I've got these contracts, let's actually go and investigate them. So the first one I'm going to go and investigate is PancakeSwap V2. So here's our PancakeSwap V2. And in fact, let's do it on BSC scan. Let's go and punch that in over here and take a look at the actual contract. So if I go here to write contract, because this is where I would theoretically perform a swap, you can see I have swap exact ETH for tokens or swap exact tokens for ETH. And here I've got swap exact tokens for tokens. This is the one I want. This requires an amount in and a minimum amount out that you want out. I'll just put 0 and accept whatever it gives us. And then a path address. This will be the order of the swap. So from what token to whatever other token. And this here will be the to address. So this is going to be essentially who's actually performing the swap, and the deadline, which we will bring as the current block time plus some buffer to make sure that that goes through within a certain amount of time. So that's the function parameters that are expected for PancakeSwap V2 to perform an actual swap. And so if I go over here now to PancakeSwap V3 and use that address, let's go here again to BSC scan, punch that in here and go to contract, write contract. And here we're going to use this one, exact input single, where we will just put in here a token in, a token out that we want the fee. So which pool fee is it? Again, we could use 500, 3,000, 10,000, whatever you want to do for your arbitrage, wherever you know that arbitrage opportunity is, who the recipient is, the deadline, and the amount in with an amount out minimum. And this price limit X96, we're just going to put a 0. Don't worry about that. And so those are the two functions we're going to be working with. So let's go over here and actually write some code which will call those functions from these interfaces we've got here. Because if I show you, for example, iSwap router, here you can see it's got every parameter we just reviewed here. So the code will know to expect that those can be called. And we've wrapped these addresses here in these interfaces as types. So we know we can call those functions. So what we need down here under the function flash loan request, if we scroll down to about here, so I would say just above get pool, let's write our function to not get pool, but this time we're going to write a function to place swap. And this is going to be a private function. And in fact, I'm going to write it with an underscore place swap. You don't have to do that. I'm just going to do that. So function place swap, and that's going to be uint 256, and that's going to take in an amount in. And then after that, we need an address, which will have two addresses in it, and that will be memory. And here we will give that token path as the variable name. And I also need a uint 8, which will be our exchange route. So we'll just call this routing. And here I'll say uint 24, and that'll be v3 underscore fee or underscore v3 underscore fee. And that's how I'm going to do it there. And this will be a private function, and it will return. So it returns a uint 256. And there we go. So what is that uint 256 is going to return? Well, if I'm swapping, say, the first token in this path for the second token, it's going to give me a different amount out because it's not an amount of the token in. It'll now have an amount of the token out. And I want to know what that amount is so that I can pass that amount out into the next swap for the full arbitrage trade. Now, remember, with arbitrage, we're performing swaps here. We're swapping from one token to another. So if we actually go and draw this up for you very quickly, we're going to have our initial token, which will swap for a token. Then we'll swap that token for a different token and that different token back for our original token. So here, let's say we started here with BUSD, and then we decide to swap for, in this case, it could be Cake or WBNB, depending on which way around we put them. And then Cake will go and get swapped for WBNB, and then BNB back for BUSD. So there's this swap going on, and this swap here could happen for various tokens on various exchanges. It's not just that all of these have to happen on PancakeSwap V2. You could choose in your exchange route that I want this as, a 1, which will be Uniswap V3 or PancakeSwap V3. So I'll just call this V3. And then this swap here, you want it to be on route 0, which would be, PancakeSwap V2. That's what we'll assign to that. And you will assign these. We'll do that now. We'll assign, which number relates to what exchange. And then here, this could be a different exchange. This could be exchange 2, which could be, bakery swap or whatever you want. Here, we'll just be using these two exchanges. So here, for example, we'll just say 0v2. And remember that your exchange route is actually passed into the flash loan request. So you can change this on every trade. This is a very dynamic flash loan smart contract that I'm showing you how to build over here. So that's what we're going to be building, is the swap function that allows us to perform a swap on any one of these exchanges. So let's head back over here to our code. Let's initialize our variables here. So this will be uint, and we'll call this deadline. And that's going to be equal to the current block.timestamp. So block.timestamp plus 30. And that's just to give us some buffer. And then here, uint 256. And we're going to say swap underscore amount underscore out. And that is going to be equal to 0, meaning the minimum amount out can be any number that the exchange is prepared to give me. So that's what I'm going to put as that. And then here I'm going to say address, and this will be as an array, will be memory path, we'll call it, is equal to new address. There, that's going to be an array with 2 items in that path, that array. And so the first item in the path, so path 0, is going to be equal to underscore token path. And here we're going to mark that here as 0 and put a semicolon on the end there. And then path 1, we're going to be doing the same thing. And again, remember the semicolons here. Now, let's first of all handle the swap for Uniswap V2. So here we can say handle for Uniswap V2. And so here we can say if underscore routing is equal to, and remember we said 0 will be Uniswap V2, so we'll assign that here. Then this is what we want to do. We want to first initialize the approval. So here we can say transfer helper.safe_approve. And then we're going to wrap in there our token path 0. So underscore token path 0. And that is going to be here for the address of PancakeSwap V2 with an amount in. And so what we're doing here is approving for that smart contract to make transfers for us. That's what we're doing. We're approving for it to make transfers with the amount that we're specifying here for that particular token. If you don't do that, it'll fail. And so that's the first step. And this is something you don't have to do when you're just making a call to this same function from JavaScript. So when you call the swap exact tokens for tokens from JavaScript, you don't have to do this. And a lot of people, including myself, get stuck on the fact that you have to actually approve it to do that ahead of time when you're doing it via Solidity, via your actual smart contract. And so here we can perform the swap. So we'll say swap underscore amount underscore out is going to be equal to PancakeSwap V2 dot swap exact tokens for tokens. So swap exact, and here this will be tokens for tokens, just like that. Open and close parentheses, and then curly braces over here. So the information we're going to pass in is going to be the amount in, which will be underscore amount in. And then the amount out min, so amount out min is going to be equal to 0. And the path is going to be equal to path. And then 2 is going to be the address, which will be this smart contract, because that's where we wanted to send the funds back to, because it's the smart contract which is interacting with all of these swaps over here. And then the deadline is going to be deadline. Now, we don't just want the answer out that this gives, because remember, this is going to be going out to swap amount out, and this will actually give an array as an answer. And so the amount out is actually going to be the second item in the array. And I know that just because I've worked so much with this function, but if you wanted to see that for yourself, you can just look at this function again on BSC scan, and you'll work out that the amount you get out is the second item in the array. Hence we use the number 1 here. Excellent. So if this is not going to be Uniswap V2, so here we can say, handle for Uniswap V3. So we'll do that here. V3. And I'm saying Uniswap. This is actually PancakeSwap. So if you want to, we can call this PancakeSwap over here. So here we can say else if underscore routing is equal to 1. And this is where we now do the same thing here again. So we can copy this transfer helper, safe approve, and this token path will be token 0. But this time we're approving it for PancakeSwap V3, not PancakeSwap V2, and also passing that amount in. Now we need to, again, perform the swap. So the way we do that is we say uint 256. We'll say amount out minimum, we'll say is equal to 0. And we'll say uint 160 square root, so squirt price limit x96. We are also going to default that to 0. And then here I'm going to say iSwap router, and this will be .exact input single params. So this is important that we get this exactly right. iSwap router.exact input single params. Memory params is equal to iSwap router dot exact. So I'm going to actually put this down here. Dot exact input single params. Open and close parentheses, and within those curly braces. And so now we're going to pass in the parameters that we reviewed earlier, and that's going to be token in. And so for token in, we're going to pass underscore token path, and that's going to be path item 0. And the other one, which will be token out. So instead of token in, we'll call that token out. That's going to be item 1. The fee is going to be underscore, and again, underscore here, v3 underscore fee. And then the recipient is going to be the address of this smart contract. Same thing as we discussed before for V2. The deadline is going to be our deadline here, which again is going to just be the block dot timestamp. And here I'm just going to add some buffer. So plus 13. In fact, I think we had a deadline up here. So yeah, I'm just going to pass in this as the deadline here. And then the amount in is going to be underscore amount in, and amount out minimum is going to be here amount out minimum, which will be this one over here. So we can just take that. And then our square root price limit x96 is going to be square root price limit x96. And uppercasing, lowercasing, all of that becomes really important. If we get any of that wrong, it's not going to accept it. Now note here, I've got this issue where I've got .exact input single param. So I need to get rid of that there. And now this cleans up this error over here. Excellent. And so here we can put swap amount out is going to be equal to PancakeSwap V3 dot exact input single. And now we can pass in these params. And remember, we've actually got these here nicely structured and organized above. So this is just one very simple line of code. And there we go. Now we have our swap amount out. And then all we need to do after this is return from this function the swap amount out. And so here we've declared our swap amount out as 0. If neither of these were the exchange route we're using, it would just return 0. Otherwise, it will return the new amount. And so that is our place swap function done. And so up here above where we've got our Pancake V3 flash callback, we're starting with an acquired amount of 0 of the second token. So our base token, which is the first token we have, in this case, it would be BUSD if that's what we're borrowing. Let's say we're swapping it for cake. If we're swapping it for cake, then the second token has 0 of it so far. And so that's why we've initialized this to 0. But when we place the first swap, it'll have an actual amount and the BUSD will have 0 because we're swapping one token for another. So let's actually go and write the code now to perform these swaps. And so we'll call this one here trade 1. And for trade 1, we're going to say acquired amount is going to be equal to underscore place swap, because we've just written the code for that. And in parentheses here, we're going to put the acquired amount. And then here we're going to say address. And that's going to be the address of the base token, because that's the initial token that we're swapping from. And the token we're swapping to is going to be from our decoded.path, which will be the first token in that. And if I look at our JavaScript code over here, that's actually going to be cake. So here's our path. We're going to swap whatever we borrow, which is BUSD for cake. Then we're going to swap cake for WBNB. Then we're going to swap WBNB back for BUSD. And so that's what we're doing here. BUSD swap for cake. That's essentially what this means here. And then decoded.exchange route, and 0 is going to be the exchange route we're swapping from. And the fee is going to be the decoded.fee. There we go. So now we can put a semicolon on the end of that. And we've got a new acquired amount. So that will call place swap. It'll pass in all of the parameters that we've told it to here. And if that swap is successful, we'll have a new amount out. But once we have that new amount out, we then need to do a second trade. And by the way, if this fails, it'll fail. You'll see it fail. It'll tell you it's failed. It'll be big and red. And therefore the flash loan will fail and not go through. And actually before trade 2 happens, let's just console.log. And we'll say here swap 1 token, just so it's very clear. And that there will be decoded, and that'll be .path 0 and semicolon on the end, and then swap 1 amount. So this will be the new acquired amount we've got. We can then see that here. We can actually console.log it out so we can see what's going on. So let's copy all of this for trade 1 and just paste it here under trade 2, because we're essentially just doing the same thing. Except now for trade 2, we've now got cake. So that's going to be the address we swap from. And then WBNB, which is the second item that we put here in our array. WBNB, that's the second item. So 0, 1. That's going to be what we're swapping to. And this is now the second trade. So we need to go to the second item in our exchange route. So we put a 1 in there. And here we've got, of course, our fee as well. And so we need to now put in here our decoded.path, which will be 1, our swap 1 amount, or swap 2, I should say, amount. So swap 2 token, swap 2 amount, and that's again just acquired amounts. Same thing as before. And then finally, on the third trade over here, so here we can put trade 3. We're going to place a swap, and that's going to go from the last item in our token path, which is WBNB, back for what we originally started with, which is our base token, right? So that's BUSD. So let's scroll down here and just update that here. So that's BUSD, and the exchange right now is going to be 2. Because it's the last item, it's the third trade, 0, 1, 2. And so then we've got our decoded fee, which is just going to be the same. And we might not use that decoded fee. Remember, it depends whether or not the exchange route is going to be PancakeSwap V2. If it's PancakeSwap V3, then it's using that fee. Otherwise, it won't do anything with it anyway. So there we have our third trade. And let me just check this decoded path. And here that's going to be the swap 3 token. And so you can look at this one of two ways. What I'm going to actually do here is print out the address of the base token here that we're ending up with. Just to be consistent with what we're doing above, I'll print that address out. So that's our swap 3 base token and our amount. And brilliant. After we've done all of this, we need to repay the flash loan, but we'll deal with that in the next session. For now, what I want to do is make sure these swaps are working. And so remember, this flash loan is actually going to fail, again, because we're not paying it back, but I'm interested still in what it's printing out. So let's go npx hardhat test. And when I hit npx hardhat test, it actually goes and runs this. It's successfully deployed it, and it's given me an error, which I expect. It's still that F1 error, meaning we didn't pay back the flash loan. And excellent, this is working just as expected. So note here we have our swap 1, which is our initial address, the CE82. So if I go and copy this and I put this into our PancakeSwap or BSC scan, I should say, over here, and you'll see that is the cake token. So we've ended up in our first trade with the cake token with that amount of that cake token. Then we've swapped that for 095C, which is WBNB, and we've got that amount of WBNB. And we swapped that amount of WBNB over here for BUSD, and we've ended up with this amount of BUSD. And so this is all working perfectly. But in order for this to actually successfully pass, what we need to do now is repay the flash loan plus the fee. And here's where you might say, well, Sean, what if this was unsuccessful? And if it was unsuccessful, looking back at this should all fail anyway. Well, it's very unlikely. We'd be very lucky if Cake and WBNB actually are profitable. So if we repaid the flash loan plus the fee, we'd be very lucky because actually we're ending up with less BUSD than we started with, because this is not a profitable arbitrage. So in the next session, what I'm going to show you how to do is to actually go and mimic another whales account, put some money in so that you can pretend like there was an excess made from arbitrage, and then it should trade and test through and you should see green everywhere. If you see green everywhere, we know it's working. So that's what we're going to come back and do in the next session. But if you got this far, well done, because you now know how to perform swaps on Uniswap V2 and Uniswap V3 successfully straight from a smart contract. And that alone can be a real headache to learn. So well done for getting this far.